Oh boy, right? Let me set the stage for you. You walk into your second block math class, and you see on your desk a piece of paper, much like the one behind me. Your heart starts racing, just like mine is right now. Your mind goes blank. You get that icky feeling in your stomach. Without thought, you raise your hand and you go, Mr. Max, when am I going to need this? Now, I've been a high school math teacher for the last 4 years, and I've been asked this question more times than I can count. And I can count pretty high. I'm a math teacher, right? For the first 3 years of my career, I felt confident in my response. Let's see. Fong, you want to be a doctor, right? You will need to use mathematics to calculate dosages and prescribe the right amount of medicine to your patients, right? Okay, cool. Let's see, Minso, you would like to be an architect. You will need to use geometry to help you draw scale models and correctly create buildings, right? Let's see, Kelvin, you'd like to be an author. You will need to use math. Well, crap, I was stumped, right? Sure, an engineer, a scientist, a doctor, all of those people will need to use math in their daily practice, right, or through university. But why would someone that wants to write comic books need to use mathematics? I mean, really, then why do any of us? That's the question that I set out to answer in this TED Talk. Right? Why? Why are we learning mathematics? Is it because some old dead white guys in the government decided it was important for us? Is it because big education says so? Is it because the snooty college admissions counselors decide that how many math classes you take in high school determines how smart you really are? I mean, why? Well, to answer that question, I first needed to understand the issue. I mean, seldom are high school students going to their English or their science or their social studies teachers and complaining about the real-world applications of those subjects, right? In fact, most students tend to really enjoy the majority of their high school classes, except for math. Why? Well, I think I know why. Math is just different from other subjects, right? In a couple of key ways. First, math is abstract, okay? Science, social studies, English, government, all of those classes are grounded in real, tangible things. It would be impossible to sever the connection that those courses have with reality, right? Whereas math has the ability to abstract far, far, far beyond the physical. Math has the ability to remove all context, and as such, can lead students to wonder, is this really important for me? Math is also esoteric. Now, esoteric means it's kind of hard to understand, and it is for a very niche group of individuals to use. For example, the word esoteric is esoteric. Oh, yes, a laugh, sweet. Math requires you to understand the syntax, the language, the vocab, the proof, the functions, the transformations of the functions, et cetera, which you don't have a solid grasp on until you're in university, right? It's not like music, where after a couple of guitar lessons, you can play the majority of the basic songs. Math requires you to have a deep conceptual understanding to truly grasp it. Furthermore, math is hyper-specific, right? When you get to university, math splits into many different fields. And actually, a group of mathematicians recently got together to determine how many different fields it splits into and to list them all into one PDF document. That PDF document ended up being over 300 pages long. This hyperspecificity leads to strong mathematicians, Fields medalists, which is like the Nobel Prize for mathematicians. It leads to Fields medalists being entirely unable to understand even the title of their coworker's dissertation. That's a problem, right? So this hyperspecificity, this esotericism, this abstraction, it leads students to be uncomfortable in math classes. It leads to that icky feeling in their stomach, okay? But since this is a math TED Talk, and since I am a math teacher, and today you are all my math students, let's pretend that we're in geometry class and prove that math is important, okay? What I'm going to do here is start by stating a conjecture. A conjecture is a question that a mathematician is interested in solving. It could be a grandiose question like the Poincare conjecture or the Collatz conjecture, or it could be a smaller question. For example, math is relevant and essential for all people to learn. Now, in a geometry class, we go about our proofs by using the axiomatic method. The axiomatic method is the process by which we reach new results from results that everyone can agree on. Those things that we can all agree on are called axioms and definitions. For example, a definition could be that a triangle has 3 sides, and an axiom could be that Mr. Max is the funniest math teacher at ASB, right? No laugh there, okay. Things that we can all agree are obviously true and as such require no proof whatsoever. Like I said, using the axiomatic method, we take those axioms and those definitions and we use them to prove that conjectures are true. When we prove that a conjecture is true, it becomes a theorem. So what we are going to do now is state our definitions and our axioms for our axiomatic method here. Definition 1, mathematics is the systematic use of logic, abstraction, and pattern recognitions to reason about problems, right? Math is the ability to use numbers and logic to solve stuff. Common sense is the natural human ability to reason about situations and problems. So it's some program that's downloaded into your brain that everyone possesses. Now let's move into our axioms. Axiom 1, the problem axiom. All people encounter essential problems that require reasoning in order to make decisions, understand situations, or determine what's true. Basically, people face problems that you will eventually need to solve. Common sense axiom. Humans possess common sense, an intuitive ability to reason about the world. Everyone has common sense. Furthermore, hello? Common sense alone can be incomplete, inconsistent, difficult to explain, or easily misled. So, math is about using numbers to solve problems. Everyone has common sense, and common sense is not perfect. So, how do I take these 5 things that everyone in this room can agree on and answer my question? Is math relevant and essential for all people to learn? A proof would look like this. 1, we have to make decisions. Every person in this room will at one point face a decision. It might be an easy decision, it might be a difficult decision, right? But you will all face a decision at some point in your life. We typically, initially, rely on common sense to make that decision, right? These are both from axioms that we agreed upon. But common sense alone can be flawed, inconsistent, difficult to explain, hard to really tangibilize. That's where math comes in. It sharpens that reasoning. It forces clarity. It forces consistency. That's from the definition of math that we all agreed upon. Therefore, since mathematics improves the way that we think, and we require thinking to navigate the world and to make decisions, it then follows that mathematics is useful for everyone. Proven, done, right? This is what our proof looks like. So let's go back and answer the question. So when am I going to need this? And the answer to that question is not sitting at your desk job and writing the answer to 35 indefinite integrals, right? No one in your life is going to ask you to do that ever. Mathematics is not about becoming a mathematician, right? It allows you and empowers you to decide what to believe. It empowers you to make tough decisions using logic from previously stated conclusions. And it helps determine if something makes sense or just sounds like it makes sense, right? Mathematics is like superpowers for your common sense. And that's something that we'll all need someday. Thank you.